Okay. So for dimension, make some categories here. Imperial. And SI units, also called metric. Okay, so here I'm just going to use the type of dimension we're going to be talking about. So if we're talking about length or like distance or something, that'll be this first guy. Second will be used for mass, temperature, time, and volume. So in imperial units, which is basically our units in America, of course we know that we use feet, right? SI units or the metric system uses meters for this type of distance. Okay. For mass, we use pound mass usually, which is you're familiar with that, right? Just pounds. But sometimes they use slugs. In SI, they use grams, kilograms, etc. Okay. Temperature, we use Fahrenheit. Or ranking. Do not have space here. Move this over. Okay. Time, luckily, we all use the same type of deal. Seconds. Which is an S, right? Same thing for SI. Although they use Celsius or Kelvin. Although Kelvin really only comes up when you have like extreme temperatures or you're doing some chemistry stuff. Kelvin's based off absolute zero. So if you are 0 degrees Kelvin, then you've hit absolute zero. And there's no negative temperature there. Like in Celsius or Fahrenheit, there is. Okay. But that would be like an extreme temperature. Gallons for volume. And liters for volume here. Now, almost the entire world uses metric SI units. There's only 3 countries that still use imperial, which is, sadly, we're one of them. So we have to deal with this. And I'm going to show you how awesome it is to convert and do calculations in SI. So doing like physics and engineering problems, etc., or just changing between units is much easier in SI. Imperial, it's not as easy, and it's a little bit more annoying, but it's also requires some rounding as well. But that's how it is, right? All right, so let's talk about what these things mean real quick. So for SI, or metric units, these will be based on units or multiples of 10. So these are based on multiples of 10. Also, these symbols that we're going to use, the prefixes, or symbols of units are not pluralized. Pluralized. So meaning if you have more than 1 meter, it's still going to be m. Like for example, I don't know, 10 meters is equal to, sorry, 10 meters in English is still 10 m. Okay, there's no ms or something. Symbols for SI units are lowercase. Although symbols for units that are named after someone, those are actually capitalized, like Kelvin. But most of the time, they are not uppercase. Okay. So also SI units are, actually, SI units use prefixes to shorten long string of zeros. So I know when when you're doing the scientific notation, changing to scientific shortens the problem. It's a lot easier to work with. SI is built to, when you have multiples of 3, or yeah, pretty much 3. You can just change the prefix and not write times 10 to the third or whatever. So SI is pretty cool. String of zeros. Although prefixes are not applied to temperature. Okay. Let me share my screen real quick. So these are the prefixes. So 10 to the negative 1 would be deci or decimal, decimeter, deciliter, etc. 10t means 10 to the negative 2, so these letters attached to a number represent these powers of 10. So if you see a mu or a lowercase m, that means this, okay? So check this out. Here's an example. 1 millimeter. In other words, 1 mm means 1 times 10 to the negative 3 meters. So one of those m's means this. And that's what this is saying. Milli. Okay. So milli is 10 to the negative 3. Similarly for, sorry, I'll close that back soon. Things that are greater than 1, right? These are the tiny ones. These are the huge numbers. So kilo means 10 to the third. Mega is 10 to the 6th. So for example, megajoule would be 1 times 10 to the 6th joules. So that capital M means 10 to the 6th of these joules. Okay. So gigajoule, etc. That G means 10 to the 9. Okay, or which same thing with like megabytes, right? Gigabytes, and now these days we have terabytes, which is pretty amazing to me. But that T means 10 to the 12 bytes. Okay, so it's getting pretty huge. When we're talking about hard drive storage space or whatever, computer storage space. Okay. All right. So let's go ahead and practice going from standard to scientific. In case I assume all of you are good at this point, but it's going to be useful to go to engineering or whatever and then put a prefix that you want. You can choose, right? Depending on the power of 10. Over here, I'll put the prefix version, the end there. Okay. All right. So let's just pick this example I have here. 43,480 grams. Okay, so this one we should all know the scientific notation, right? This would be 4.3480 grams. Times 1, 2, 3, 4, 10 to the 4 grams, right? Now in engineering, we want a multiple of 3, so we would use 43.480 times 10 to the third grams. So now remember, 10 to the third is going to be what kind of unit? If grams is metric, so this is 10 to the third grams. So what letter should we replace 10 to the third with? Which prefix?
You're saying based off that chart you showed us earlier?
Yeah, I'm going to show it to you again.
Okay.
There you go. Based off this chart, so this is how it works, right? Can get you the chart. 10 to the third means kilo, right? So just replace that number with K. That makes sense. It's a good guess. If it was -3, we would put milli. Okay, so then that would be 43.480 kg. Now it's implied that it's thousands of grams, right? Kilograms. You see how easy it is to shift to a different unit, right? There was not much thought here. But if you're shifting to, like if we were in imperial, like using our American units, going from feet to miles to whatever isn't that easy. You don't just move the decimal and we're done, right? You have to do conversion factors, which we'll talk about later. Is there any questions about this first example though? Does that make sense? Or?
No, sir.
All right. 0.0351 seconds, right? So it's not a whole second, it's a fraction of a second. So first is do scientific. that would be 3.51 times 10 to the 1, 2, negative 2, right? Seconds. Now, if we want to use engineering, we should move 1, 2, 3 times, right? So this will be 35.1 times 10 to the negative 3 seconds. So now, right, this is going to be milli, right? Milliseconds. So 35.1 milliseconds. Okay. Let's keep going. Let's do a couple more and then we'll move on. Here, 0.00986 meters. The first thing is do scientific. So that'd be 1, 2, 3, 9.86 times 10 to the negative 3 meters. Right? So you're technically already in engineering, right? It's already power 3, so just leave it alone. And remember, engineering can be written in different ways. It doesn't have to be one specific way. Scientific can only be written in one way, right? Okay. So then that will be, again, milli, right? Millimeters, millimeters. It's understood to be this small. All right, one last one. I'll move on to a different section. So 1, 210, 0, 0, 0, 0, 0, 0 watts. Okay, so that's what? A billion, 210 million watts, 1.21 billion watts, right? So thousands, millions, billions. Okay, just double checking. So then watts is capitalized, which is most likely a name of a person. Oh, don't worry about that right now. Let's convert this to scientific. We know the decimals at the end. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this should be 1.21 times 10 to the 9 watts. And since 9 is a multiple of 3, we know that that will be so the same for engineering. Now 10 to the 9 is pretty huge. So that will be 10 to the 9, positive 9, right? Should be giga. So we have gigawatts. So quite a bit of electricity here, right? 1.21 G, capital G, watts. Okay. Alright. That's pretty much it for this new section. When we cover the SI units and the why they're awesome. Okay, so let's move on to conversions then, and why the American system is not awesome. So it's just my opinion, and most of the world, but whatever. All right, let's keep on going here. So this guy will be conversion. So when we're dealing with the imperial units, we have to do conversions. And if you want to go from imperial to metric, the conversions get more complex or require some rounding, right? So let's go ahead and do it. On this guy, I'll give you more examples than actual topics here. Most of you should have seen this in chemistry. And if you haven't, or physics, and if not, I'm sure you'll see it right now. Okay, so we use, let me go ahead and send you that PDF real quick, actually. Okay. I forget. So there's our chart. Okay. It will also be in Canvas if you forget to download it before the class ends, but feel free to save it now. It's in the chat box. So we use conversions to change between units. And the method of conversion factors sometimes feels like it's not necessary because it can, a lot of you, I remember myself, I would do it in my head and wonder why else should I do it this way? But when things get very complex, it is better to use this method. Like if you need to convert 6 or 7 times in one problem, then yeah, you don't want to do that, in your head or, just a quick estimate. Units and units, prefixes, and systems. Like for example, this question will seem pretty easy because you should all know the answer, but that's not the point. The point is to use conversion factors. Changing from 11 feet, 3 inches to a single unit. So it's not having 2 different units in one measurement is just silly. It should be in one. Okay. So if I'm going to convert the feet, right? Let's say I want it on inches, then I'd have to convert the feet, correct? So we're not going to mess with the inches in that case. Okay. So you would only look at the 11 feet. So we know 11 feet would be written first here. Oops. Where's that better? For this question, we'll use the conversion factor. There is 12 inches equal to 1 foot, right? So that's the thing we should already know. So this would imply that you have a conversion factor of 1 foot per 12 inches, or 12 inches per foot. And these are the actual conversion factors. And I know that they're not necessary for something that's easy, but it's the process of what you want to learn if you don't already know it. So you take the initial measurement or unit, multiply by one of these conversion factors. Now, the one you want to cancel or convert from, it should be on the bottom. So if I'm leaving feet to go to inches, then I better use the one that has feet on the bottom. if I'm going to the other direction, right? If I'm going from inches to feet, then you should have inches on the bottom. And what I'm saying is, you want the one on the bottom that will cancel the current units that you're in. So this feet will cancel that feet. And yes, again, we already know the answer to this. The process, so it's important. So that will give us 11 times 12, which will be in inches, right? Because the feet unit is gone. So 11 times 12, what's that going to be? Is that 132? Yeah. 132 inches. Okay. Does the idea make sense? I'm going to make a note here. I use this specific conversion factor, to cancel feet and go to inches. So now, if I were to go the other way, right? If I want everything in inches or feet, if I want feet only, then all I need to change is the 3 inches. So you take 3, multiply it by the correct conversion factor. So I'm going to choose this factor, right? Inches on the bottom, so I want to get rid of inches. So inches will cancel, leaving me with 3 feet over 12, which will reduce to 1/4 feet, which is really what? 0.25 feet. So the total amount, right, you just add it to this. So this is my weird scratch work, right? So the answer would be 135 inches. On the short work here. This one. 4 inches for feet. We would take the part we converted and add the 3 that it came with, right? Because we only converted the 11. So this is 11 feet right here, plus the 3 that we had extra. So the answer would be 135 inches. Right. Now, if you want it all in feet, well, you take the 11 feet and add that decimal. So we would have 11.25 feet. Okay, so that's what the question was saying. Get it all into a single unit. So combine it, what's appropriate. Okay, is there any question on this problem? Okay, all right, let's keep going. So that was feet. Feet and inches, right? Stuff we should already know. Convert from meters to kilometers. So the thing that we need to know is that 1 kilometer is equal to 10 to the third meters, right? Because we know what the K does. And my K's look weird, but just remember, it's supposed to be a lowercase K. So, let's write the, let's first come up with a question, I guess. Here's 3,200 meters, right? So you would multiply by the conversion factor. So remember, this will make two different conversion factors. So we have 1 kilometer per 10 cubed meters, or 10 cubed meters for every kilometer. And since I'm canceling meters, I'm going to use this guy. Oh, sorry, this one. So meters will cancel, right? I'll be left with 3,200 kilometers over 10 cubed, which will be 3.2 kilometers. Because remember, since this is these SI units, you can simply just take that decimal, move it over 1, 2, 3. We don't have to really do much. That's what the 10 cubed does to you, right? That's why this is easier. So instead of using the conversion factor, you could just look at this question, right? And say, well, if there's 32, oh, sorry, this should be, yeah, that's fine. If there's 3,200 meters, if I automatically change it to scientific, I would see that this is already kilometers, right? This is why this this type of system is much more ideal based on our rule of 10, right? Base 10. Anyway, is there any questions about this example? Okay. Okay. Is there another guy? Question. This time we'll do more difficult conversion. Convert kilometers to centimeters. So this should be a pretty big number. Right. So if you know that 1 centimeter is 10 to the negative 3 meters, maybe we can use that guy. Go ahead and write our conversion factors. So this means that 1 centimeter for every 10 to the negative 3 meters, or 10 to the negative 3 meters is 1 centimeter. But if I'm going to convert kilometers, then I need a kilometer conversion, right? Which we wrote earlier, I believe. Here, 1 kilometer is 10 cubed meters. So let's write that over here. 1 kilometer. It's also in that sheet I gave you, I guess. So this would imply 10 cubed meters for every kilometer, or 1 kilometer for every 10 cubed meters. Okay. All right. So we're going to do multiple conversions here. So you could do it one step at a time. So we're going to kilometers to centimeters, so kilometers to centimeters. So first I got to cut the kilometers, then get to meters, right? And then once I'm in meters, I can use one of these to cut meters into centimeters. The book, or I guess people in general, usually convert this way. They'll write the whole thing like, all right, I'm going to get rid of kilometers and go to meters, and then right after that, I'm going to get rid of meters and get to centimeters. So the one that you want to convert to will always be at the top, and the ones you want to get rid of go on the bottom. So this cancels meters, right? This cancels kilometers. So I no longer have any other units except centimeter. So then you end up here. Wait, I made a mistake. 1 centimeter. Yeah, I think this is wrong. Let me check that chart. I feel like I forgot something. Yeah, centi is -2, not -3. Otherwise, I would just cancel. It doesn't make any damn sense. Yeah, right. -2. 2. And a 2 there. Talk about that. So this is a 2. All right. Double check everything. Yeah, that's right. Sorry, I got paranoid. All right, so then once everything cancels, you just multiply this out and you're good. So you would get to here, 32 times 10 cubed. Remember, if a power is negative, you can bring it up top and make it positive, right? Back from our basic algebra. And the centimeters is just waiting for us to deal with it. It's already done though, right? So 10 cubed times 10 squared will be 10 to the 5th. Centimeters, which is actually a huge number, 32 with 5 zeros. 1, 2, 3, 4, 5. 3,200,000. I wrote that pretty ugly. 3,200,000 centimeters. Is there any questions about this? Does it seem difficult to do it all at once? If you don't want to do it that way, you could do piece by piece. I'm going to do it real quick. You could do this one first, right? Cancel the kilometers and you'd be left with 32,000 meters, right? And you do that math there. Then you can take the 32,000 meters and multiply by conversion factor to centimeters. 10 centimeters over 10 to the -2 meters, right? That'll cancel the meters, which will get you to 32,000 times 10 squared centimeters, which will end up to be the same deal. 3,200,000 centimeters. If you prefer to do it this way, that's totally fine. I'm not making you do it one way or the other, but I do want to see you apply the conversion factors when you do your exam or homework. Okay. I don't just want to see, like, for example, I don't want to see you just take 11 and multiply by 12 or something. That's not the point. Okay. Alrighty, let me go ahead and share this next PDF with you. Okay. If you have any questions, we're just about out of time. If you guys have any, you want to ask anything about your last homeworks or your lab stuff, because I know that stuff is due, I think, tonight or maybe already due or something. So, you guys all right?